What's up, everyone? Welcome to Geometry with Mr. G. Today, talking about similar triangles, lesson 8.1. So notice we're talking about triangles that are similar this time. Oh, there we go. Triangles that are similar this time, not congruent, right? We're talking about similar triangles. So they're not the same, but they are similar. Congruent means same shape, same size, right? So that's what congruent is. We know that by now. Similar means it's the same shape, right? If it's a triangle, it's still a triangle, but we have a different size, right? Different size. So that is what similar means. Let's go into more detail on similar. So for similar triangles, the symbol is, we use the squiggly, which in the past you may have seen we use that for conditional statements. It meant not, right? Not P, not Q, not Q, not P. In this context, when we're talking about now, this means similar. So we're talking about similarity when we see the squiggly, okay? Second bullet point says all three corresponding angle pairs are, all angles remain congruent, right? That's what that means. All angles remain congruent. All three corresponding sides are proportional. And that just means that every single side of one triangle is multiplied by the same scale factor to give you the new triangle. That's what it means to be proportional. And then K, which again, if you remember, this is our scale factor. That tells us how much bigger or smaller the triangle will be. Our formula for scale factor is K equals new over old. Right, this will be big. We'll be using this for a while. Cool, so let's look at this one here, number one. This example. We're going to put everything we just talked about in the above box and put that to use, showing you, number one, some examples here. So, in the diagram, RST, triangle RST is similar to triangle XYZ. Okay, so this right here is called a similarity statement. This is called a similarity statement. We're saying that RST is similar to XYZ. Okay, cool. So let's look at A. It says list all pairs of congruent angles, okay? I want my congruent angles. So for example, let's say I start with angle T, okay? So angle T. Well, angle T is congruent to, so watch how I like to do this. I like to go up here and look at my letters. So these letters here, and these letters here, right? And I like to do, I call it the rainbow. You look at R comes first here, which means R corresponds with X, right? We make a little rainbow there, because X comes first on the other side of that statement. S comes second, matches with Y. T comes third, matches with Z. So T and Z correspond with each other. So you actually have all the answers right there. Angle T, which corresponded with Z, right? So angle T is congruent to angle Z. Angle S is congruent to, well, S matched with Y, so angle Y. And then angle R is congruent to angle X. And that's it. That's how you list all the congruent pairs of angles. And we can also do that in here, right? I can add some arcs here. So T, I'll put single arc, and Z, S and Y, so I'll put double arcs for that one, X and Y. And then we have R, so I'll put triple arcs. Right, just like that. Those are all the corresponding angles that are congruent with each other. All right, cool. And then part B says, write the ratios of the corresponding sides, this is big, right? The corresponding sides in a statement of proportionality. So watch how we do this. It sounds like a lot of words. It's super easy, I promise. The biggest thing you got to remember here is corresponding, what this actually means. So same location, same spot, right? That's what corresponding means. You got to refer back up to our rainbow, right? We got to refer back up to our similarity statement up here. This is going to be our savior right here. So for example, let's say I begin with this side RS. So this side here, right? Color one, I'm coloring in green. So I have RS. Well, what does RS correspond with on the second triangle, right? On the other triangle. Well, again, R and S, if you look here, that's our first and second letter. Well, our first and second letter on the other side is XY. So RS corresponds with XY. And we write it like this because remember, when we're looking at our sides as a proportion, proportions are dealing with fractions, right? We're dealing with fractions in our proportions. So RS corresponds with XY. I'm going to use different colors for this. Which should equal, well, let's pick another side. Let's do TR. Do this in yellow. So we got TR corresponds with, well, TR, right? TR with one, RT is here, R is here. That's our first and third letter. So that's going to be our first and third letter over here, right? ZX. So ZX is right here. Those correspond with each other. And then let's change to another color now. Equals, we got one more side, right? One more side here. What's the last side I haven't used? I haven't used TS. Right, TS. Or let's do ST, right? Let's just call it ST. It doesn't really matter. I'm just going to call it ST just so we can do, okay, second letter and third letter. Second letter and third letter, right? So TS corresponds with YZ. And YZ is over here. I'll color that in red. Cool, so we have a color coded. We have all the sides that correspond with each other. So, and that's it. That is how you write the ratios in a statement of proportionality. Let's look at part C, which is just as easy. It says find the scale factor from RST to XYZ. Guys, this is important. The word to here, right? We're going from, this is important, from RST to XYZ. Because if you remember our formula for scale factor, right, up here, this is our formula that we're using for this. Should be thinking to yourself, new over old. Well, which one's the new and which one's the old, right? This tells you we're going from RST to XYZ. So obviously that means RST is going to be our old, and we'll put an O there for old. And we're going to XYZ. So that's going to be our new. And I'll even go over to the picture and I'll put an O in here. And I'll put an N in here saying new. That's our old triangle and our new triangle. We're going from here to this one, right? Obviously it's a scale factor based on this, right? Scale factor K. Let's go ahead and erase that. Try that again. What I'm trying to say here. Come on. There we go. Scale factor K should be less than 1, right? Since it's a reduction. So since reduction. Cool. Right, we have a reduction, so the scale factor should be less than 1. We know that for a fact. So let's go ahead and apply our formula. So we've got new over old equals. So you literally just pick any side from the new triangle. It doesn't matter, right? We have 15 we can use 18, or we can use 12. It does not matter which side you pick. So let's say I go with 15. If I choose 15, well, 15 is my yellow side, right? X to Z. That corresponds with what? On the old triangle. The yellow side on the old triangle was R to T, which is 25. So it's going to be 15 over 25. And 15 over 25 reduces to, just divide both sides by, or divide the top and the bottom by 5. What is that going to be? 3. So 15 divided by 5 is 3. And 25 divided by 5 is 5. So there is our scale factor, 3/5. Or as a decimal, that would be 0.6. Yeah, 0.6. So there's our scale factor. Obviously, we know it's less than 1 because it's getting smaller. So then moving on from here, let's take a look at the second problem here. It says in the diagram, DEF, triangle DEF is similar to triangle MNP. So there's our similarity statement. Find the value of, and we know that, I guess when we start here, D maps to M, right? E maps to N, and F is corresponding to P, right? So D is corresponding M, E corresponds to N, and F corresponds to P. Cool. Find the value of X by using the scale factor. Okay, cool. Now, in this one, it doesn't say we're going from a certain triangle to another triangle. So you might be thinking, well, how do I determine which one's the old, right? Because remember, scale factor equals new over old. So you might be thinking, which one's the old and which one's the new? If it doesn't clarify which one's the old and which one's the new, I generally just go in order from left to right. So this one, this triangle here, right, came first. So I'm going to put old. This triangle here came second, so I'm going to call this one the new. And the reason we're okay with that, to be honest with you, is because it doesn't necessarily matter. We'll get the same answer either way in this case. So how do we do this? Well, we know it's new over old, so equals. Let's go ahead and choose a side from our new triangle. Remember, you can choose any of these numbers. Let's choose 24. That's just the one I wanted to use. Well, 24 is MP, right? So it's using the first letter and the third letter from this similarity statement. So we need to look at the side on the other triangle. It needs to be the side DF, first and third, right? And so this is MP, the side we used, DF, right here. So the 24 corresponds with 20. 24 over 20. Well, 24 over 20 reduces to 24 divided by 4 is 6, and 20 divided by 4 is 5. So that reduces to 6 over 5, which, as a decimal, if you want, you can actually turn that into a decimal, and you would get 1.2. So this is equal to 1.2. And that's our scale factor. Our scale factor is 1.2. Let me clarify exactly what this means. What we're saying is we're doing 20 times 1.2 to get 24. We're going to do 15 times 1.2, right? 15 times 1.2, should put parentheses here, which means we're also going to do x times 1.2 to get that side, right? Every single side is being multiplied by the same scale factor, 1.2. That's how the triangles remain similar. So what I can do here is we can actually say that this side x, right, this side here, corresponds with the 30. X corresponds with the 30. Let me change colors here, make it a little easier. Right, x corresponds with this 30. So we know that x times our scale factor, 1.2, has to equal 30. So let's just solve for x. Divide by 1.2. Divide by 1.2. We're going to get x equals 25. And that's how you solve for that side. So let's keep going on to the next problem, number 3. You'll see a lot in this lesson. There's a lot of opportunities to do some kind of cross multiplying or setting up the equations and solving for x. A lot of things to do with sides being proportional. So like number 3, we're continuing the same thing. It says the following triangles are similar. Find the missing side using proportions. The following triangles are similar, right? That's our key word. Now this one's going to do it a different way. You could do it exactly the same way we just did on number 2. You can do it exactly just like that. But I'm going to show you another way you can do this. This actually, in my opinion, might be the easier way to do it. We know that, this one's a little tricky, right? We've got which side corresponds with which. I'm going to use 3 different colors. So let's circle the 30 with green. You'll notice the 30 is in between the triple arc and double arc angle. So if we go to our other triangle, we have 12 in between the triple arc and double arc angle, right? So 30 corresponds with 12. So you got to be really careful here because it's the other triangle, right? The new triangle, not only has it been reduced to a smaller size, but it's also been kind of spin around, rotated. So you got to be able to identify that. Let's use red for the next one. So I'll circle this 25 red. That's in between the triple and single. Triple and single. That's going to be our X over here. And then that just means we have one last color pair. So 20 matches with 8, right? We don't have to really put much thought there. We know that's going to happen. So here's what we can do. We can actually set up proportions just like we did before in problem number 1, actually, where I pick a side, right? We can say, again, it doesn't really tell us which one's old, which one's new. We're going from or to. So I'm just going to make this one the old and this one the new. I'm going to continue with that same process of new over old. And I'm going to choose 8 over. Well, 8 corresponds with 20, right? So I'm going to do 8 over 20 equals, well, we have to use the x, right? We're trying to find x. Remember, that's our goal. We're trying to find x here. So I'm going to do x over, what does x correspond with? X corresponds with 25, right? We circled those in the same color. And just like that, you've set up a proportion that we can now solve by using the butterfly method or cross multiply and divide, whatever it is you have called it in the past. So we've got 20 times x, which is 20x, equals, and you got 8 times 25, which is 200, right? Let's solve for x. This should be really simple. You divide by the 20. Whatever you do on one side, you do to the other, right? divided by 20. This is going to give you x equals 10. And there's our answer. X is 10. And that's number 3. Easy. Let's look at number 4. We're going to continue this similar process we just used. Again, just to make it easier, we're going to do it the way we just did on number 3. I like that method better. I think it's a lot easier. And let's look at, we want to solve for y this time. So this time we're looking for y. Well, I have the y minus 1, right? The y minus 1. Let me go ahead and erase that and try that again. There we go. Which corresponds with the 16, right? And that one's really obvious because we're talking about the line that's inside the triangle. So the y minus 1 corresponds with the 16. That's going to be one color. And then the y, which is here, right? It's in between this single arc and, of course, this angle here, which have no arcs, right? So on this other triangle, single arc, no arc. So the y corresponds with the 18. Now, and that's pretty obvious, right? Because there's no other number in the picture. I just wanted to tell you or show you the process of how I know, how do I know for a fact that the y corresponds with the 18? So let's go ahead and set up our proportions here. So I'm going to use, again, you can do it however you want. You can do, this is the old, and this is the new, if you want, this whole triangle over here. And if I do new over old, then I'm going to get 18 over, 18 corresponds with y, equals, we're going back to the same triangle now, 16 over y minus 1, right? You have to make sure you start with the same triangles, new over old every time, new over old every time. So let's go ahead and do our butterfly method and figure this out. So I'm going to get y times 16, which is 16y, equals, I got to put that equal sign there, 18 times y minus 1. Now this is important. Watch this. 18 times, so parentheses, y minus 1. You have to write it this way so that you make sure you are distributing the 18. If you do not do this, you will get this wrong. So that's our first step, is to distribute, actually. We're going to get 16y equals, this is going to be 18y minus 18 because of the negative sign. So it's going to be a minus 18 there. Now let's continue to solve for y. I'm going to do minus 18y minus 18y. Whatever you do on one side, you do to the other. That's going to give me negative 2y equals negative 18. Last step to solve for y, we're going to divide both sides by negative 2 so that we get rid of these negative 2's here. Whatever you do on one side, you do to the other. So we're going to get y equals, well, negative over negative turns into a positive. 18 divided by 2 is 9. So our value for y is 9. And before I finish up with the last problem, I'm going to give you your code word for this one. And the code word for this one is going to be something cool. Let's go with Colt's rule. There's your code word for this one. Let's do the next one now. Number 5. All right, cool. Make this kind of quick. We've got, what is the perimeter of triangle HNK? Tells us that HNK is similar to triangle ANC. So that's big that it told us that. So again, I'm going to look at this. I'm going to go, okay, well, we've got this triangle here, which is with sides 6, 8, and 10. That's easy. But you should see, or you should be able to visually see, there's another triangle here, right? This triangle here, the N to H, H to K, and K to N, right? That big triangle. So we have two triangles here, and those are your two triangles that are similar. So what you're going to find out is that our scale factor, which is, remember, scale factor equals new over old, actually works the exact same way for perimeter. Now, in this one, I'm going to tell you that I actually like to draw, I'm going to redraw these triangles for you separately. Watch this. I'm going to draw this real quick. We have that little triangle, ANK. So this is not ANK, ANC. Then we have the giant triangle, right, which is the whole thing. This is going to be HNK. Okay? Now, the problem is asking us for the perimeter of HNK. We're looking for the perimeter of H and K because if it asks for the perimeter of A and C, well, you already have that answer, right? This is 6, this one's 10, and this is 8, right? You can find the perimeter of that. The perimeter of A and C here, the perimeter equals 24, right? But the question is, how do I find the perimeter of this triangle, HNK, right? How do I find the perimeter of this one right here? Right, all we have is this side here, which is the 10. We're missing we're missing this side here, right? And we're missing this side here. Missing that side as well. Okay? I'm actually going to get rid of that X here. So, a couple ways you can do this. Again, scale factors, new overall, thinking which one's new, which one's old. I know in the past I've said, hey, whichever one comes first, right, I'll call that my old, I'll call that my new. You can do this, and it will work. There's a way to do this. I'm actually going to show you another way to think about this, another easier way to do it. We're looking for the perimeter of H and K. So I'm going to treat H and K as my new, and I'm going to treat A and C as my old. And the reason I'm doing that again is because we're looking for the perimeter of H and K. That's the one I'm looking for, right? I already have the perimeter of A and C, right? That's like, I already have that number. Those are original numbers. It's 24, boom, done. Let's figure out the original of the perimeter of H and K. So I'm going to call that one my new this time. And you can get the same answer. There's some different way to do it, just different way of thinking about it. This makes the problem easier, in my opinion. So if I do that, I'm going to get, well, I know that the 10, if I use different colors here, right? The 10 corresponds with the 8, which you can see that over here on the picture, right? Here on this picture, 10 corresponds with 8. So we're going to get 10 over 8 for our scale factor, and that reduces to 5/4, right? 5 over 4. Well, the reason why I wanted to show you this is because the way scale factor works with perimeter is the perimeter of the old times scale factor, right, times K equals perimeter of the new triangle. So again, what's the perimeter of the old? Well, the perimeter of the old triangle, was 24 times the scale factor K, which was this number here, right? So 5 over 4 equals, and the perimeter of the new triangle, which we just put this in the calculator to get the answer for, right? So 24 times 5 over 4 gives you 30. And there is your final answer for the perimeter of triangle H and K.